Swayam Prabha. Digital India. Educated India.
Now we will go into the demo where we will see some of the concepts for tensor data. Okay, so tensor data we have seen, right? Now, how we can define the tensor data and how we can use different functions that is as similar to your NumPy functions that is similar. So we will use Colab. Okay, I hope you are seeing the window for browser. So here we are using Colab to run this previous, let's say TensorFlow 1. Now to use TensorFlow, you just need to import. So if you are using local machine, you need to install TensorFlow and you need to check which versions you are using. So TensorFlow version is very, very important to confirm so that you are not using TensorFlow 1. And here in all the tutorials, demo sessions, we will use TensorFlow 2.x, any versions up to 2. Okay, that is fine. So if you are using your local machine, you should ensure that you are using TensorFlow version greater than 2.0. Now tensors, as I was mentioning, defining tensors is very easy. So basically, this is a string tensor, which we are defining as variables, right? Now this is a single dimensional scalar with rank 0 string, okay? And this number is again another rank 0 tensor, which is again a variable, floating variable. Now you can see that tf.data type you can use, okay? And several data types you are using. Now these data types is very important in model training, because in the previous class also we have seen that with mixed precision training we can enhance or improve the performance manifold, and using different types of data and exploring your design model is very, very important to see how you are improving your performance, both performance and how it affects your accuracy. Now rank, as I was mentioning, that if you want to see that rank, let's say I want to see this TensorFlow rank. So basically, this is a single dimension, and this is two-dimensional, right? So the rank of rank 2 tensor is basically NumPy 2. Okay, so 2 rank. So this is the two-dimensional tensor. So you have 2 rank. And shape of the tensor, so it's rank 2 dot shape. Now 2 rank means it has 2 dimension, and in each dimension you have 2 elements. So 2 by 2 is essentially your shape, right? So understanding shape of the tensors and rank of the tensors, these two are very important, because to compile the model that you have defined, you will get different shape and ranks of the tensors. So rank is essentially how many dimensions are there. So let's say if you are training the model using batch, so how many batches you are using in each layer, that will come as rank. Okay, and the shape, then how many elements in each dimension, so that is the shape that you will. Now changing the shape, you can use reshape method to actually change the shape. So here we have this once created shape as 1, 2, 3, right? So all the elements in this tensor is essentially ones. Now I want to reshape this 1, 2, 3 to 2, 3, 1. Okay, so tensor reshape, and tensor 3 is reshaping to 3 minus 1. So minus 1 is telling you how many elements will be there automatically in this dimension. So here in the first dimension we have 1, second dimension we have 2, third dimension we have 3, first 2, 3, 1. Here we are saying first dimension we have 3 elements, and in the second dimension we do not know, infer it from the reshape. Okay, So same -1 you have used before in Python. So printing this, the tensor 1, tensor 2, tensor 3, that is the different tensors that you have initialized. So you can see 1, 2, 3 shape, right? Completely one element 1, 2, 3. Tensor, the second tensor was actually 2, 3, 1, right? So 3 and 2, so 2 total of elements and 3 elements in these 2 elements, and total of sorry, 3 elements and 1 actually element in each dimension, right? So 1 element in each dimension. Now in the third, you can see that that shape already taken as 2 because we had -1. So it will automatically compute how many elements will be the second dimension. So this is basically 3 rows and 2 columns matrix. Slicing tensors. So this is also important if you're using different data types in different shapes. So basically here we have defined one 2D tensor, and then we are actually selecting, let's say, third element from the first row, selecting the first row completely, selecting the first column, selecting the second and fourth column, and printing all the column values here. And then we are selecting column in one in row 2 and 3. So column 1 in row 2 and 3. So basically column 1 from 2 and 3. Okay. So this is the column 1 value 0, and from 1 to 2. So basically 0, 1, 2. So basically 2 and 3 row you are accessing. So basically, if you see the outputs, you will see the tensors, uh, uh, whatever tensors you have got. So first we are accessing the element from third element, which was 3, right? So 3, and then you are accessing the first row, then the first column, then the second and fourth row, and then the first column in row 2 and row 3, right? So this is the first column in row 2 and row 3. And you can see the shapes and different data types that are being used. Okay. Now different types of tensors are there: variable, constants, sparse tensor, and placeholder. Placeholder is not recommended also in the 2.x versions. So you can go to this uh, link to see more of this usage of tensors. So this is just few basics that I wanted to cover for the tensors, because these tensors we will use almost in all the layers that we want to define in the model. Right? Now coming to the model. So what we have told that you can define your models by using sequential API, you can use functional API, plus. So basically customized callbacks, your customized optimizers and so on, and then subclassing. And in this tutorial, we will see the usage of Keras API with sequential paradigm. Right? So importing the necessary versions. So now percentage TensorFlow version 2.x, this comment is necessary if you have multiple versions available inside your system for TensorFlow, and it will actually force to use the 2.x version level. We are just importing then the Keras, the API functional API, the Keras high-level API from TensorFlow. We are not using the TensorFlow, the Keras IO library, which is the native Keras. We are not using. We are using TensorFlow. Helper libraries from NumPy and matplotlib just to work with arrays and plotting. Now in the data set, you can see we are using Keras data set here, okay, not the TensorFlow data set. So all these things you should keep in mind while you are programming or doing the model definition, because most of the students or researchers I have seen that they just copy some code from somewhere else, but they do not know what kind of pipelines that are being used, because TensorFlow has several options, several combinations, several compositions of different APIs. So if you're not aware of which API you are using, you will not be able to accelerate your train. So that is why here we are using Keras, just keeping in mind, okay, just because to be sure that we are just extracting, unpacking the training images labels and test images labels from the fashion images dataset, that dataset you have seen also previously. And we are using dot shape attribute to see how many images that training images have, right? So after downloading, so basically we have downloaded everything. Now you can see that 6,000, that is the number of samples that is available, 28 by 28. So you can see the correspondence with the numpy. Okay. So we have got 60,000 images. So train images just to see what is there in, let's say, 23 by 23 pixel of the first image. You can see 194. So the values here actually varies from 0 to 255. So basically, what is to be done to be pre-processing? In the pre-processing part, you just need to normalize it with 255. So that is what we are doing here. The same thing you have seen in the data loader for the Python PyTorch for the train sets and test sets pre-processing of the data. Class names we are extracting and saying that these many classes will be there and these are the names of different classes, right? We have extracted the models. Now data pre-processing part is essentially just normalizing. Okay? Now again, all these operations are happening inside your CPU, okay? And we are using simple numpy arrays and numpy operations. Okay, so simple math that is operated on the array. Okay. Building models. So now we will try to build the models. You can see that we are using keras.sequential API, sequential API for beginners, and all the models, model layers, what are defined for. Let's say you are targeting classification problem, you are targeting LNP problem, as I mentioned. So there are numerous numbers of layers that is already defined in Keras. So Keras TensorFlow, you go to that website for Keras TensorFlow and see how many layers that is already available in the sequential API. So as layers, we are using flatten layer and dense layer. Flatten is essentially the helper function to flatten your input array. Okay, so this is exactly the input layer. So in the PyTorch also, so every time you will just need to see the equivalence in the PyTorch. Okay, so you just visualize whatever we have seen so far and what we are seeing in further classes. So in the dense layer, so this is the dense layer. Basically, this is the fully connected dense layer or linear layer that you have seen so far. Right? So again, I am mentioning that you go to Keras sequential API and see what are the layers of output tensor dimensions. So 10 is the output number of neurons that I want from this dense layer because 10 classes are there. And activation value, again, all are predefined. Activation, softmax. So basically, we are just defining these layers. So dense layer. So it will take whatever you are giving input from here and give output as 128 neurons with this activation. And then we will have the second dense layer, so two-layer definition model that we are defining here. And you can see in the output, we are having 10 classes here. So this is just as simple of definition of model. And there is nothing else you need to do. This is very simple sequential API. Definition of layer 1, 2, 3 that you can see here. But what is most important is that model.compile. Now, this is the eager execution. So when you are using this compile, then at this time itself, you are actually compiling your model. Without running the model, you're actually analyzing what are the attributes for the layers that you have defined. Is that correct or not? All the parameters that you have used for defining your layers. So I did not know So if you are working elsewhere, if you are not using compile, then you are not essentially taking the efficiency of eager execution. As long as you have defined it and run it, the graph is already defined and evaluated for compile. So basically in the compile, we are seeing all the things that you have defined is correct or not, and compile time check you can do it. Then if we just, so everything is okay, there is no error, you can fit it for the training images and training labels for this many number of epochs. So you can see how easy it is to define one model training with, so defining layers with sequential API and training model with fit method that you have seen in the slides. So on what? Training images, train labels, and epoch. That's it. And it will train it. But before that, you have already checked your model is correct or not, right? And evaluating the model is, again, it is easy with evaluate method. Okay, so model.evaluate. So all the things we are doing here is sequential API, and we are not using subclassing or functional API. So we will see subclassing and functional API with the different data distribution strategy that are available in tf.data in the next class, but just get familiarized with the simple beginners APIs that are available with TF. So we'll go in advanced model definition in the coming class. So you should be aware of these simple models definition. Now printing the testing accuracy. So all this, so when you are actually calculating the evaluation, you are getting the tuple for the loss and accuracy, and you can print it. Okay. So this is all these are actually abstracted. You do not need to define anything. So basically, if you want to verbose the output or not, that also you can define. Now we can actually test that. So basically, testing accuracy that we have evaluated, but to test, you can call this predict method to get the predictions, and you can use these predictions. So basically, which prediction index has the highest prediction probability? That's it, right? So you can get it, right? Which is the argmax. Okay. Right. So now we want to verify the predictions. So basically, whether your ninth level is actually correct or not. So here is simple function. This is nothing to do with training or evaluating. So this is just we are checking whether the ninth level is fine or not, accessing the particular index. Okay, indexed image, and you can go to these links for detailed definitions of or different optimizations that you can use in the TensorFlow and so on. You can also visit TensorFlow sequential API to see what are the flexibilities you can have, like how much you can go with the fit and predict and evaluate. Right? Now we will see a bit about how we can actually compute in GPU. So basically, this is a bit different from defining the device for in PyTorch and transferring the data into your GPU and modeling inside the GPU. Here, actually, you have much more flexibility in terms of accessing or offloading the tasks or pipeline of your training module inside your GPU. So that way, the distributed training of TensorFlow is much more efficient. So in this class, we'll just see how to define the GPU and then how to define the program codes which will go to your GPU or TPU rather, depending on the device you want to access, or CPU, I don't know. So here, accessing to your importing your module and then device name is essentially tf.test.gpu device name. So whether what kind of GPU is available, GPU 0. If not found, it will raise the error. So you just change the runtime type to GPU if you're using Colab, right? And if you have already in your local machine, if you have GPU, then well and good. So now in the TensorFlow, how we will offload the task, right? So basically, device name we have gathered, if whether it is a GPU or it is a CPU or it is for the TPU, we have not written the code here, so we'll just see the CPU and GPU here. TPU maybe we'll see in the next class. Now for the CPU, so basically diff CPU, this function I will run. So basically with tpu.tf.device, if it is CPU, then this segment of code I want to run. So what segment of code I am running here? Again, you can see that keras.layers.convolution2d. So this is again defined in keras.layers. And some input random image I'm creating with 100 batches of 100 by 100 into 3 channels. Okay, so this is the tensor dimension. Okay, so again, the rank, the shape. Okay, so you just correlate to the idea of the tensors, that the predefined concepts. So basically, this is giving the output of your convolution 2D of this random image. Okay. Again, this is what kind of layer that I will not tell you now, but this is just I'm running one layer of one model just to see whether it is running in CPU, and another layer we are defining here, net GPU, and that also we are running inside our GPU. Okay. So we'll call these two methods to run both in CPU and GPU. The same dimensions of inputs we are running here, and actually just to see what kind of achievement we are getting, we have called these two methods and printing the time taken by the two devices, right? So as you can see, we are getting 67 times just to simulate one layer only. Okay. So, but you can see, right? So defining functions with devices, like which device will run this piece of code. That flexibility is something that we'll exploit in distributed training. Okay, so basically, we'll distribute. Of course, there are several abstractions of the APIs. You may not exactly define like these functions, but this is giving you an idea that yes, we can customize our pipeline much more efficiently with what kind of device it will use. Let's say you have tensor processing unit available, GPU unit available, CPU available, multi-core CPU in multiple nodes. Now this is where we will see that whether this piece of code you want to run in GPU or this piece of code you want to run in TPU, right? And numerous examples will be there to exploit this distribution strategy. Of course, as I was mentioning, that there are several abstractions of these strategies that you can use directly without defining that this piece of code will go to this piece of device. But the strategies in underlying these are the techniques that will be used to actually distribute with different strategies that we will use. Okay, with this, we will conclude today's session, and